Assalamualaikum and very good morning to all of you. So today I want to present my research title is Implementation of Deep Learning Network to Detect Distracted Driving Behaviors in Night Driving. My name is Muhammad Firdaus bin Ishaq, student Master of Science CEE 750 semester 3. So here background of the study. So deep learning is a subset of machine learning, which is essentially a neural network with more than 3 layers. So deep learning model can detect distracted driving behaviors when driving at night. So one of the main cause of the accident is distracted driving. The rise in number of automobiles in Malaysia is increasing. So around 1.35 million people worldwide lost their life in traffic accident every year. So at least 20 million more suffer injuries. So the total number of road accidents in Malaysia over past decade have increased by approximately 41%. So we have 7 distracted driving behaviors. So number 1 is normal driving. Second is yawning. Third is nodding off. Fourth is using phone for texting. Fifth is using phone for calling. Next is talking to passenger. And last is interact with the car feature. MobileNet V2 we use in this study as a deep learning model CNN with 53 deep layer to detect restricted driving behavior. So next is IR and VIS camera. We use IR camera and DVR camera as VIS camera is used to analyze how well the suggested model perform in spotting distracted driving behavior at night than during the day. So S32V234 NXP vision processor we use in this study. It can offer an ISP and a powerful 3D graphic processor unit. It is dual apex 2 vision accelerators, automotive gradability, function, safety, and security capability. We will go through the status of major research milestone for the next slide. So we go to problem statement. For the first problem statement is rate of accident increasing. So due to driving behavior, automated detection of behaviors faces difficult challenge in night driving. So difficult to achieve better performance to detect image due to low illumination and low light level. So for the second problem statement is a lack of nighttime driving behavior comparison between VIS and IR images in previous research. So this is the behavior recognition is better when driving in daylight. In daylight, the image capture clearly on eye closure, body texture, and mouth closure. The challenge challenging to detect driving behavior during night driving. So next is the problem statement is to implement the solution as a complete hardware prototype will pose an engineering challenge. So investigation need to be done on how well the behavior detection system performs is actual in actual environment. Next is research objective. So for the first objective is to implement a CNN LSTM deep learning model to detect distracted driving behavior in night driving. Second objective is to evaluate the performance of the proposed model in the detection of distracted driving behavior in night driving compared to daylight driving using IR and VIS sequence images. So last objective is to validate the prototype of the proposed model based on implementation of the S32V234 processor. For next is research question. So the first question is how to design a CNN LSTM that can detect driving behavior at night. And next is what is the difference in terms of performance between IR and VIS images in detection of driving behaviors. Next is how to improve the detection performance using IR image. And next is how to validate the performance of the detector on the S32V234. Next is scope and limitation. The high performance detection which are an LSTM model that can achieve good generalization and an LSTM architecture that can deliver fast on-board processing. Next is mobile net V2 is used and it is a specific kind of CNN LSTM network. Mobile net V2 outperform the other models and offers a suitable compromise between accuracy and processing runtime for deploy in the real world. Next is useless brightness because it is challenging to maintain flawless competition when driving at night. Next is we use 44 people in this research. 44 people are participating in the data collection process. So we use only there are only 7 drowsiness driving behavior in this study, such as normal driving, yawning, nodding off, using phone for texting, using phone for calling, talking to passenger, and interact with the coffee chat. Last is this study will use only the middle camera DVR and IR camera. So next is significance of study. So the 11 suitable development goals, making cities and human settlement inclusive, safe, resilient, and suitable is communication and suitable cities. Next is the agency of disaster risk reduction is acknowledged and reaffirmed in the 2030 agenda for SDG goals. So next is the finding of this study will improve the ADAS system, which can detect driving behavior and can contribute to achieve the 2030 agenda of SDG goals. Next is this study can reduce the percentage of accident and on the road if we can monitor distracted driving behavior in night driving. Next is the research will have a positive impact in improving the safety of the vehicles as well as the road users. So next is a literature review. We have two methods of detect distracted driving behavior. So first we have conventional. Next is vision based. So for conventional we have EEG and ECG. So for the next vision based we have hybrid and framework, efficient D3, Darnet, YOLO V3, and Inception V3. So now we have a literature review on computer vision under poor light, which is using absorption light scattering model ALSM and using generative adversarial network and BSDL method. And next is using mobile net V2 for face recognition, improve the pedestrian attribute detection accuracy using Google Net, and using ResNet for face detection, using VGG 16 and 19 to identify 4 classes of dementia. Last is using LXNet for classify lung tumor. So next is conceptual net framework. So we have a flowchart of the framework and summary of research. So we have for flowchart literature review, data collection for stage 1 and stage 2 for system development, and stage 3 we have prototype integration, and next is thesis writing. Here we have research methodology for data collection and hardware and software setup. So we have first thing for flowchart for data collection, we go to set up hardware platform and create 2 session video. Next, reserve slot for participant and sanitize and sign consent form and briefing. Record video for day and night driving. Next, we process the data. So the video we use 20 minutes and 45 seconds. Then after get the output video, we extract into the images. So we have the setup here, hardware platform, OBS Studio software, and we have IR camera, DVR camera, and Logitech camera. So in here we have a data collection procedure. So here the procedure of for the normal driving, the left hand must be at the 11 o'clock of the steering, and the right hand 2 o'clock of the at the steering. So for the yawning, we have covering mouth with the left and right hand, and not covering mouth. So next for the nodding, we have front, right, left, and back. And next, using phone for texting, we we have left hand and right hand. It must be on the phone must be same level with the steering, and the phone must near to chest of the participants, like here. Next, using phone for calling. Um, Also, we have left hand and right hand. So for calling, left hand for the left ear, right hand for the right ear. So next is talking to passenger. We look the participant need to look at the left paper that has emoji while driving, and look at the right. The participant need to look at the right paper that has emoji while driving for the right passenger. So that is interact with the car feature. We use calculator at the left side and the right side of the table. So next is data processing. We have 44 participant data. Edit the video using Geosoft software, and labeling the distracted driving behavior process. Next is we use 3 frames per second extracted image from video. So this one is a camera placement. We have left, middle, and right. We have all total in 7 camera. In the middle, we have 3 camera, IR, DVR, and Logitech. For the left and right, we have only 2 each, DVR and Logitech. So next we go to modeling. So we use MATLAB to model the process, and we use also server to which is modeling on the server with great processor. So we have 64 gig RAM and NVIDIA A5024 gig. So next we use mobile net, CNN with 53 layer dips. So here we have image classification with mobile net, and confusion metric for the target class, and the architecture for mobile net. Next is data analysis, comparison of night driving performance against day driving. So first thing we have to modeling the performance by using MobileNet V2, and then compare the performance between IR night vision and VIS DVR camera day driving. So here data analysis for CNN LSTM. So here we have a figure 24 predicted class for CNN. So overall we have the result for accuracy is 69.3%. So figure 25 shows that the conversion metric for CNN LSTM. So next is we have data analysis for LSTM. So here we have figure 26 for predicted class for LSTM, and figure 27 for coefficient matrix for LSTM. So the overall accuracy is 83.2%. Next, we have hardware development for S32V234 processor. So it is provide an additional integrated development environment that enables editing, simulation, compilation, and deployment of design from MATLAB environment. So next, provide designer with a simple development tool that makes programming mission accelerator easy. Less is utilizing this toolset can speed up development. So we for in figure 28 is block diagram of S32V234 processor, and figure 29 workflow for the model deployment of the processor. So next we have here preliminary result. Table 2 shows that 7 distracted behavior on day drive, night drive, and IR camera. So we have normal driving, yawning, nodding off, and using phone for texting. All in this picture is different participants. So next, preliminary result for table 3 shows that 3 distracted driving behaviors on day drive, night drive, and IR camera. So we have using phone for calling, and next is using talking to passenger, and last is interact with the car feature. So next is Gantt chart. Table 4 shows that the Gantt chart for my study. So January 2023, I need to improve the accuracy and need to do the system integration and optimization implement on S32V234 processor, and writing thesis for publications. So status of publication is now 20%. Next is status of thesis writing, which is also 20%. So planning for next semester is continue thesis writing, continue training data to improve accuracy, and last integrate and validate the performance of the S32V234 processor NXP Visions. So that's all from me. Thank you.